My name is Faisal Yahmadi. I am from Sultanate of Oman. And before I start, I want to say that I am pleased to have this opportunity to present in this conference. This is my second publication. I am a final year undergraduate student, and today I will try my best to explain to you and to present to you my paper titled Malicious Node Detection in Smart Grid Networks, written by me and supervised by Dr. Ahmed. In this presentation, I will start with an introduction about smart grids, why it is such an important technology that will come handy in our future, and why we need to protect the smart grid. Then I will give a brief about my first published paper titled Taxonomy of Threats and Vulnerabilities in Smart Grid Networks, which holds the background that I built my protection software in. Then I will explain in detail the second published paper titled Malicious Node Detection in Smart Grid Networks, explaining the various steps and various steps and measures that we took to help protect the grid. After that, I will conclude with some of the challenges that I faced and future work of my research. So to start, as an introduction, we are all sure that electricity is a fundamental necessity in the 21st century. Therefore, any breaks in electrical power is probably going to affect the general activities. Anywhere from hospitals, airports, schools, or any other services will have a limited functionality with the non-stable grid. And most of the grid that we are using today have been built around 50 years back, which means the grid is becoming old. So in order to deliver a sustainable and efficient power supply that will meet the growing power demand of our century, Smart Grid Networks, or SGN, is introduced. So what is Smart Grid Networks? We can say that Smart Grid Networks is an emerging technology that utilizes the developed infrastructure to overcome these different upcoming challenges. Smart Grid Networks is heavily based on the information and communication technology, ICT, which grants the network the ability to introduce more features to the customers and service providers. Some of the benefits of implementing Smart Grid Networks are we will be having a more efficient and reliable grid, and that will give us the ability to integrate alternative power sources, which will lead also to a greener or give us the ability to satisfy the growing global power demand. And the grid also provides customers with more solutions and freedom to utilize their personal power usage patterns. These benefits have been made possible with the implementation of smart meters and other smart devices within the grid. After all what I've said, it is a promising technology. However, with millions of these smart meters and smart devices connected to the grid, the system complexity will increase. And these smart devices in each household are within the hands of millions, which can be manipulated, which ultimately threatens the grid operation and security. These possibilities poses major security concerns for both the customer and the service provider. And we won't forget that the implementation of any new technologies in any system will be posing many security threats that were not dangerous before. All of that have been investigated in the first paper and provided a possible solution in the second paper. The first paper was accepted in the 15th International Conference of Smart Grid Cybersecurity. The conference was held in Dubai on the beginning of April this year. My paper titled Taxonomy of Threats and Vulnerabilities in Smart Grid Networks. I will open the paper now to give you a glance. You can check the paper in online just type in that title. Since it has been published in a public domain, it will give a brief background about a smart grid cybersecurity. So in this paper, the focus is to investigate the threats and vulnerabilities in smart networks, and then we aim to study the existing solutions provided by other researchers. So we have researched the threats that SGN will be facing both in physical and cyber, and in a survey-like paper, and researched some of the solutions that other researchers have provided recently. And after doing that, we came to the finding that there is a need to develop solutions in smart grid networks to help protect the grid. Now, after we have devoted a full research paper identifying that threats, now we have an idea what are the threats that we have, and we have an idea what the researchers have done recently. So here comes our part in the second paper, which has been accepted in this conference, the International Conference on Smart and on Networks, Communications, Wireless, and Mobile Computing. The paper is titled Malicious Node Detection in Smart Grid Networks. Here's a snapshot from the research paper. You can check the full paper in the conference proceedings. In this paper, we aimed as an objective and have successfully proposed an SVM model-based software that detects malicious attacks in smart grid networks. The model works by collecting data from smart meters, which in later slides I will be referring as nodes, and compares it with the data that we have set previously in the software. And in order to understand the paper methodology, I broke down the system operation in 3 vital steps. The first step is obtaining data from the nodes or smart meters. Here we can see on the right side, a diagram shows the wireless sensor networks, which shows how data is being collected. Here the nodes, represent smart meters, which will be fitted in all households connected to the grid. The data is gathered from these nodes and sent to the supplier through the internet, through the central node. The supplier in this case is our software or our system. In step 2, the data gathered will be processed and classified into 2 groups. Either it will be given a status of a positive one to indicate that the node is functioning normally, or it will be given a status of -1 to identify the node as malicious or attacked. And that classification depends on whether if the data gathered does or does not match with what we have set previously in the software. And here on the right side, you can see a diagram of linear classification, which is the basic classification technique. Linear classification separates 2 groups with noticeable differences. As you can see here, a blue group is separated from an orange group. However, the data that we have, which are obtained from nodes, as we explained earlier, are not reliable and are much difficult to classify. In this case, the system will face difficulties classifying those data. So that's why we used machine learning technique called support vector machine, or SVM. As we can see on the right side, SVM has the ability to classify unrelated data. We can see here 2 graphs, A and B. On graph A, we can see a green dot closer to the blue group and a blue dot closer to the green group. So if we are using linear classification, those 2 will be misclassified. So what SVM does is a technique called kernel mapping, which moves the graph to a higher dimensional domain. So in graph B, we can see the introduction of a Z domain. It's no longer X and Y. We can see here introduction of a Z domain. And now the system And according to many mathematical equations, and I put one of the measures here on the left side, the system or the algorithm will be able to classify this data with ease and achieve a high successful attack detection rate with minimal misclassifications. And to show the results, on the left side, we can see a screenshot of the algorithm graphical user interface, or GUI, modeled in MATLAB software, which is where the operator will have the ability to interact with the software. We enter the required parameters to the system as we please here, and then we can click the Generate Network button to start the process of simulating network generation. And the results, which will be shown on the right side here, network display, the generated network will be shown here on the right side. The network that I chose to sample is consisting of 75 nodes. Each black dot represents a node, which, as we explained earlier, it is a smart meter or a household. And on the right side, we can see the network after attack detection have been done. And that is when we click detect attacks. So when we click that button, the system will do the classification from the data obtained from each node and put a red circle around what has been detected as attacked. As we can show here, it has been detected that there is attacked node and it has been highlighted. To conclude, I started with a survey-like paper to provide me and the researchers the necessary background to develop our solutions. I did study many recent proposed solutions by other researchers from around the world and came to a finding that there is a need to develop solutions to protect the security of smart grid networks. In this paper, in the second paper, and based off the necessity of the first one, we developed a solution based on machine learning technique called SVM to identify the attacked or malicious nodes in the network and publish the results in this conference. Finally, we have simulated the algorithm in MATLAB software, and it shows a promising result of successful attack detection accuracy approximately of 98%. Some of the challenges that I have faced in the research process is that I had to study many research papers, approximately 40, and I had to find and identify the shortcomings of each solution that was provided in the paper to learn from them. The second challenge was that I had to carefully investigate many algorithms to choose what's suitable for my application for smart grid cybersecurity. And after that, I faced a challenge implementing the algorithm in a hypothetical smart grid scenario, because this is a simulation. And lastly, I had to learn how to implement all my findings, algorithm and mathematical equations in a form of codes in MATLAB software, and to create a graphical user interface, GUI, so we can interact with the system and set the desired parameters in a language that the system understands. Ending with the future work, we are currently working to extend the results and examine algorithm in a bigger scale, aiming to submit an international reputed journal. And we are hoping that the results of the research will be published soon, inshallah. Further research will be done for the implementation in a hardware level, since this one is only software. And an extensive research is also going to be done to accommodate different scenarios, such as a dense area or a light populated area, and these scenarios. Also, the research has a possibility for a funding from a council in my country called the Research Council. So that's also a good thing. This is the end of my presentation. Please, if you have any comments, suggestions, questions, feel free to ask. And yes, thank you.